This conference will now be recorded.
All right, and I will cast my screen here. Can everybody see the slide presentation?
No, I can't.
You can't see the slides?
No.
Okay. All right, I see a bunch of no's. All right, let me go back and try to cast again here. All right.
Oh, yeah. Now I see it.
Perfect. All righty. Thank you so much. All right, so we will begin here. I will start from the beginning. Here we go. Okay, so we will get going. Thanks, Mike. Thanks, Brent. And thanks, Jeff, also for replying. And we will get started here. My name is Mike Pontrelli. I'm the Regional Sales Manager for Stenner Pump. I'm based out of Valparaiso, Indiana. And what we're going to do is we're just going to go through a company overview on the Stenner Pump Company Peristaltic technology. We're going to go through our classic pump and discuss some different service items that come up most commonly on the classic. We're going to also review how to select, identify pumps, how to size them properly. That seems to, as far as wear on pumps, sizing tends to be the biggest culprit for undue wear on a pump. We're going to go through some installation and maintenance. I'm also going to cover some different things that I see in the field and different things that you could do to help maintain the pumps. And then we're going to go through a product review. Last week, Stenner just introduced a version that's a step up from our classic pump that we're pretty proud of. And it's basically a classic pump with some mechanical controls and a NEMA 4X enclosure so that it has a more robust motor. So we'll go through that in more detail, and then some other items that you might want to consider aside from the classic pump. So first off, Stenner, we've been in business since 1957. The business was started by a gentleman by the name of Gus Stenner. Gus Stenner, there's an interesting story about Gus Stenner. Gus Stenner was an engineer who had lived in Connecticut, and he was one of the key guys that was responsible for getting the tolerances correct on bomb sites for the bombers during World War II. After he retired, he moved down to Florida, and he had seen that the resort market, as far as pools and so forth in Florida, was growing very rapidly. So he felt that there was a need to have some type of a constant feed pump for the pool and resort markets. And you can see from the picture here in the slide, that's what the first Stenner pump looked like. It was just basically a metal box with a motor. But in general, the design hasn't changed much. We manufacture our products in 3 different locations: Jacksonville, Florida, Albany, New York, and New Century, Kansas, which is right outside of Kansas City. What this allows us to do is to provide 1 to 3 days of manufacturing time and in roughly about 1 to 2 days shipping time. So most folks that are serviced by Nelson, their products are coming out of the Albany, New York facility. One thing that we do is we pride ourselves on being able to ship the product complete. We manufacture 90% of our components in-house. We do our own plastic injection molding. We manufacture our own tooling. We do our own metal finishing. The only items that we don't make are wires, screws, fasteners, things like that. If you ever have a question or need support, whenever you call up on our 800 number, the phone will be answered by a live person, and then you'll also be connected with a live person. So someone in tech support's always going to be there to help and support you, especially if you're out in the field. There's been times when I'm in somebody's basement or in the back of a pool room for a swimming pool, and if I get stuck on something, I'll call tech support to try to go through some troubleshooting with me, and I'm always able to get somebody on the phone. So peristaltic technology. So the idea behind peristaltic technology is to be able to squeeze the tube to maintain suction and vacuum. And with that, we're always able to get 2 points of contact on the tube. So the rollers are always squeezing at least 2 points of the tube at all times to maintain prime and to prevent fluid from falling back. So why would you want to choose peristaltic pumps over a diaphragm pump? Well, some of the main characteristics of a peristaltic are, number one, peristaltics are self-degassing. We can prime up to 25 feet. We can handle heavy viscous fluids. You're not going to have any backflow with the pump, and you can run the pump dry. So if you do run out of fluid, the pump can continue to operate with not causing any damage. With diaphragm pumps, you need a degassing valve. Usually they're limited to about 3 to 5 feet. As far as prime, a lot of times they're prone to creating backflow, back pressure, and then also it's not uncommon for the pumps to lose prime also. So with our classic pump, this is our most popular pump, and it's the pump that's been around the longest. We've made some design changes, but it's your basic adjustable feed rate control. Some of you might recognize these pumps as 45 or 85 series pumps out in the field, or 100 or 170 styles if you're looking at a double head. So with the classic pump design, what makes the classic pump design so unique is that we have the QuickPro head, which will allow you to engage and disengage the rollers by using the cover on the pump housing. We have 6 tubes, 2 motor speeds, and I'll explain the motor speeds a little bit later when we talk about the gearing. You can interchange pump heads to convert from one pump to another. So if you're using an old style classic pump with screws in the cover still and the old roller, you can purchase a new QuickPro housing and mount it on your Stenner pumps that use the old style heads. One thing on the pump is that you have a 2.5% increment adjustability on that too. So with our classic series pump, we offer an adjustable version and a fixed rate version. On our adjustable version, we have an 85 gallon per day output flow when you're looking at the highest flow output tube with the number 5 tube. At pressures up to 25 psi. When we start getting into pressures from 25 to 100 psi, our max flow rate is 40 gallons per day. When we look at the 2 pumps, we have some customers that will go to a fixed output pump and operate the pump at max flow and just turn it on and off depending on the flow switch, but then they'll adjust the flow rate based off the tube. And then here we show our classic adjustable as far as in the double head version. Most people in the water conditioning market are going to tend to stick with a single head pump. So to help you identify the pumps, and this is something that comes up often, if you're going to call into our tech support line or if someone calls me, what we're going to ask is, what is the model number on the pump? What the model number is going to tell us here is the gearing. So if we look at that top number, the 85 MHP 17, what that's telling me is that this pump is a pump with a 85 tooth gear set. And the 17, what that represents is that it represents a 17 gallon per day max output flow. And in this case, that could be achieved with an 85 series pump with a number 2 tube. So after hearing this, more than likely when I will hear that part number, I would know that this pump had a number 2 tube in it. So one thing that's so nice about a Stenner pump, if your flow rates are too high or too low, if you need to increase or decrease the flow rates, you can always adjust that flow by changing the tubes. And then on the bottom here, you'll see a serial number. When I look at the serial number, the first 2 numbers represent the month. The second 2 numbers represent the date that it was manufactured. And the 5th and 6th number represents the year that it was made. So in this case, if you're trying to figure out if a pump is under warranty, so we base warranty off of 2 different scenarios. One, either by the final bill of sale to your customer when they purchase it, or we will go by the serial number on the pump itself or the date code. In this case, because this pump has a 1-year warranty, the pump itself would technically be out of warranty. When we size the pump, this chart's a great little pump, chart. We have this available on our website also. If you're unable to find it, certainly let me know. We can get this chart off to you. But what this pump is doing is it's walking us through the 45 and 85 series. Now, most people that are working in the middle water conditioning side are typically going to use 100 PSI max output flow pump. And you're going to, in many cases, I see pumps operating in that 40 to 60, sometimes 70 PSI range. So on the bottom of the chart, where you can see my arrow here, we would want to focus on the pump, arrows right down below, or the chart down below here, where we have a 1, 2, and 7 tubes on our 45 series, and our 1, 2, and 7 tube on our 85 series. So when I'm sizing a pump, the first question I would ask a customer, or I would determine, is what is my flow rate? What does my flow rate need to be in gallons per day? Based off of that, I will always try to size the pump so that if you're using an adjustable rate pump, you want to size it so that you're always operating it at 50% or higher, or at a level of 5 or higher on the feed rate control dial. So, and how do we figure that out? Well, what we'll do is we'll use the number 1 tube on the 45 series here for some simple math here. If we want to operate the pump at 1.5 gallons, then we would take, that would be 50% of the total max output flow for that tube, which is 3 gallons per day. Same thing with our 85 MHP 40 here. Max flow output is 40 gallons per day, and if we operate that at 50%, or 20 gallons per day, we would be operating that pump at 20 gallon or 50%. So what you're always trying to do is you want to try to size the pump that you're and try to select the tube. You want to try to size it as close to your max flow output as possible. We recommend running our pumps with adjustable feed rate controls at settings of 5 or higher. The closer you can get to 100%, the better. There's many times I go out in the field and I see customers running pumps at 1, 1.5, and 2, and very quickly the feed rate controls will start wearing out in 3, 4, 5, and 6 months, because the pins, as we will show you in a video, the pins in the feed rate control rise and fall frequently then on the index plates. So how do we build a part number? I always like to show this too. When we go back on the chart, where we have our item prefix. What we're always going to do is we're going to fill in our item prefix. From there, we would specify if it's a 120 volt or 220 volt. Most cases, you'll see 120 volt. In some cases, if you're plugging into static switches, you might run into 220 volt. Tubing, we offer white and black, and both 1/4 inch and 3/8 inch. If you're mounting this pump in an area where it's going to be exposed to sunlight outdoors, and we run into this quite often in Florida, you more than likely want to go to a 1/4 inch black tubing. And as far as tubes, probably 95 to 98% of the time, if you're dispensing bleach, hydrogen peroxide, or anything like that in the water conditioning market, you're more than likely going to go with the Santoprene tube. The only time that you'd have to go to a Versalon tube is if you're pumping oil-based chemicals and products. Now, when we talk about sizing, this chart gives us a good breakdown as far as how to size the pump. So once again, in the world that we're working in, the water conditioning market, the tubes that we would use most frequently would be a number 1, 2, and 7 tube. So those are the only 3 tubes that you would need to worry about if we're operating in that 40 to 60, 40 to 70 PSI range. Now we talked about how do we change the flow rate on the pumps. Well, we can change the flow rate in 3 different ways. One was by the tube, where we can change the tube. A second is by changing the gearing inside the pump itself. So if you see a pump listed as a 45 series or 85 series, that's the number of teeth that are on the gears inside the gear case. 45 series pumps are always going to run slower at 45 RPMs versus 85 series at 85 RPM. You do have the option to, after you purchase a pump, if you do need increased flow, where you can add a second head to the pump. So installation points. I have a video here that I want to run through with everybody, and then after the video, I'm just going to go through some different points afterwards that the video doesn't cover that I feel that are important.
Mount the pump vertically with the pump head in a downward position and never with the pump head pointing up to keep solutions from collecting in the tube housing or seeping into the feed rate control and motor, which can seize the moving parts. With a vertical mount, the rain roof slides onto the mounting bracket to help protect the ventilated motor from water intrusion that can cause motor damage. The rain roof is recommended for outdoor environments and installation subject to washdowns. To help prevent chemical from collecting in the tube housing, which can cause the rollers and the roller assembly to seize and damage the tube, and to reduce spillage on the floor, a spill recovery can be set up using a section of the 1/4 inch suction discharge tubing inserted into the tube housing cover. The tubing will help drain chemical back to the tank in the event of tube failure. The suction and discharge lines are installed to the pump tube fittings with a compression type seal consisting of the connecting nut and ferrule. The beveled end of the ferrule faces the tube fitting, and the suction and discharge line should bottom into the tube fitting. The connecting nut is secured into the fitting finger tight only and not tightened with pliers or wrapped with thread seal tape. Pliers or thread seal tape should not be used because the pump tube fitting is secured to the tube material by an internal seal consisting of a crimped brass collar, and on some of the tubes, the brass collar is under a rubber collar. Using pliers will break the internal seal and cause the tube to leak, and using thread seal tape will interfere with the seat between the connecting nut and ferrule. If using 3/8 inch connections, keep the tube fitting stabilized and attach the female end of the adapter to the tube fitting. Slide the line through the 3/8 inch connecting nut and finger tighten to the male end of the adapter. If a leak occurs, gradually tighten the 3/8 inch connecting nut as required. The suction line should be 3 inches from the bottom of the solution tank to prevent picking up sediment. Sediment pulled through the suction line from the tank bottom can damage the pump tube and cause blockage or restriction in the check valve ductbill. The ductbill is used on applications above 25 psi. The insoluble sediments can create back pressure that exceeds the pump tube's pressure rating and will damage the tube. Install Stenner's weighted strainer on the end of the suction line and keep the suction line from the nose of the strainer to prevent blockage that could interfere with the pump's priming ability. With both the suction and discharge lines, allow slack so the pump tube fittings can flex to prevent stress on the pump tube and fittings. The slack helps reduce the chance for breaks on the tube fittings causing leaks. Mount the
Okay, so with the video, I always like to show this drawing, and I always like to stress how the pump needs to be mounted, because I can't tell you how many times when I go out in the field, I see customers mounting the pumps with the head facing up, and they call me in a panic because the pump's been flooded full of chemicals. So we just make sure that we always want to make sure that customers are mounting the pump so that the head's always facing down. You can also mount it horizontally if you want to put it on a stand, but we never want to see the pump with the head facing upwards, because if you do have a tube leak, everything's going to flow into the motor housing, gears, and feed rate control and just cause a mess. So when we send the pumps out, we have 2 injection fittings. Every time that you order a pump that's rated for 25 to 100 psi, you're always going to get a check valve with a ductbill. So every time that you're changing tubes, we recommend also replacing that ductbill. What the ductbill does is it guards against back pressure, backflow. So in a lot of cases, if we see splitting tubes on the pump, more than likely a split tube is caused by a worn ductbill. So it's always a good thing just to change the ductbills every time you're changing the tubes. We also recommend mounting the injector in a T between the 2 shutoff valves, and this just makes it easy to replace the tube and to service the pump because you're able to relieve pressure on both ends. And then we also talked about the assembly of the connecting nuts. The only thing that you should use to tighten the connecting nuts on the pump tubes and also the injector fitting is just your fingers, and you don't have to get crazy with it. Those little ferrules inside there, the green ferrules, will seat very nicely if you put them in there correctly. When we talked about the spill recovery, this is the drawing that we had seen in the video as far as the spill recovery. How do you do that? Well, you can punch it out with a 7/32 punch or 1/4 inch number 2 Phillips head screwdriver. In my case, just so that it's easy to take care of it and get the tube in there correctly, I'd recommend just taking your 7/32 drill and just drilling out the hole. What that'll allow you to do is attach a 1/4 inch discharge line that can just then be used as spill recovery. So if the tube does break, it's not going to flood the pump housing chamber. It'll give fluids a place to go. This is an item that's optional, does not come with the pumps, but we always recommend it. It's a flow indicator, and I recommend going with the flow indicator because it's a nice positive way to tell if there's fluid flowing through the tubes. I can't tell you how many times customers will call up dealers and they'll say, I have no fluid going into the water lines. And if you try to ask a customer to look for the bubbles in the water in the chemical lines, sometimes that's hard for them to do. With this, you have the ball that will rise. So if there's ever any question and they do call you for service, If you know that the ball is sitting on the bottom of the indicator, you know there's no flow. If it's up in the air, then you know that fluid's flowing through it. So that might save you a service call. Once again, we talked about not using tape, not using tools, just finger tighten. With the ferrules right here, you want to make sure that the mushroom end is facing the tube. If you put the ferrules in backwards, there's a good chance that they will leak. So you want to make sure that you always have the mushroom end facing the tube. So maintenance on a single head adjustable pump. And what we're going to do is we're going to go through how to change the tubes and how to service the feed rate controls. That's what I see most common out there. If you need any assistance or help or want to learn more about how to change gears, service motors, we can go through that a little bit later. But this is the most common stuff that you'll find. So with our Classic Series pump is made up of 3 parts: the motor, feed rate control, and then the pump head. And where the gears are located in the case that's right in front of the pump motor itself. As far as cleaning and servicing the pump, you just need a few basic things. A utility knife to cut the end of your suction and return lines. Needle nose pliers come in handy for taking the duct fill out of the injector fitting. Fantastic is great for cleaning up the pump and the pump housing, especially if you've had a tube leak. Phillips head screwdriver also come in handy. So as long as you have these items, you should be able to service a Stenner pump. One thing that I recommend is that anytime you do have a tube leak, because I see this happen often, if you do have a tube leak, we recommend taking all of the parts out of the head, taking the roller, shaft, take the housing off, and clean everything with some good clean water. And then also clean it with some Fantastic, and especially the rollers. If one of the most likely things that happens when you have stuck rollers is when the chlorine starts getting crusty, it starts hanging the rollers up, especially after a tube leak. So here we're going to go through the pump tube basics. This is our QuickPro head, which you can use to convert over the old style heads, which we mentioned earlier. And when you look on the inside here, it has just a few parts: the latches on the outside, the pump tube housing, the QuickPro roller assembly, pump tubes, and then the cover. The only thing that's missing on here is the shaft. When we go through the tubes, and I've mentioned this before, the 3 tubes that you need to be focused on are number 1, number 2, and number 7. So tube wear and failure. A few things that will cause that is lack of service to the pump head. So if you do have a leak, and I see it on a tube, and you replace the tube without cleaning out the pump head, what that'll do is possibly hang up the rollers, and that'll lead to excessive tube wear. Not handling the tube properly. I've had some people that try to stretch these things like rubber bands. You don't need to do that. Back pressure, and the excessive back pressure usually comes from worn out duct bill, and then chemical incompatibility. Now, when you look at the pump, this is the most common question that comes up: is how do I tell if the tube needs to be replaced? So on the outside of the housing of the pump, you can do a visual inspection without taking the head apart. So if you see a teardrop pattern, then you know that the tube's in good working order. Anytime that you see a diamond or oval pattern or some other type of shape on the tube going through the tube housing, we'd recommend replacing the tube. So conditions that reduce the tube life, not following the instructions. We see that happen often. Storing the tube in high ambient temperatures. So I've had some guys that they feel that they want to try to loosen up the tube. When they're in their truck going on a service call to try to loosen the tube up, they put the tube on the dashboard in the hot sun, or they put it next to the heater. Those will all contribute to reduced tube life. In the wintertime, when I'm going out to service a pump for a customer, first thing I do is since we're only dealing with 3 tubes, I'll take a number 1, 2, and 7 tube. I'll put it on my car seat and I'll sit on and I'll just sit on the tube and just warm it through body heat. You can also put it between your hands and then just roll it with body heat to give it a little bit more flexibility. But never stretch it. Never put lubrication on it. We don't recommend that. I've had some people fill up the entire roller housing with lubrication. That's not necessary, and we don't recommend that. I had this come up one time. Customer was trying to loosen up the rollers, and they loaded the rollers up full of Vaseline. So Vaseline is a petroleum-based product, and Santoprene does not work very well with petroleum-based products. So you can probably imagine how fast that tube wore out. Once again, we keep stressing finger tighten, don't use tools, don't use the thread tape. Now, as far as seized rollers, there's really no way to unseize a roller once it's become seized. The best scenario is to just replace the rollers. Make sure that you're following the factory recommendations, and then also inspect the housing cover. So sometimes if somebody runs a pump dry, or after a tube rig runs it for an extended period of time, sometimes you'll see cracks on the front cover and the bushing of the cover on the pump housing or the tube housing. So it's always good to replace that cover if you do see something like that. Another cause that will create excessive wear when you do have a chemical leak, the chemicals, if they're not cleaned off the shaft, will rust the shaft, and in some cases they will almost weld the rollers to the shaft itself. So that's another example. Now, as far as reducing the tube life, every time that I change a tube, I'm going to change the ductbill. And we always feel it's best practice to take the end of your Phillips head screwdriver, stick it through the injector fitting just to get rid of any rust, calcium, or anything else that might collect at the bottom of the injector. I don't have a picture of it here, but what I also recommend doing is on the end of the injector fitting, cutting the end of the injector fitting at a 45-degree angle. And when you place the injector fitting back into the T, you want to make sure that you're placing it in there so that the long side is facing the flow of water. And when you do that, when the water goes by, it'll reduce the chance of sediment and build up on the end of the injector fitting, because it kind of acts like a Venturi effect to try to keep it clean. But it's still, we still recommend, even if you do put that 45-degree cut on there, to still clear it out with that number 2 Phillips head screwdriver every time you're servicing it. Here we go through the instructions on how to replace the ductbill, and of course putting the weighted suction strainer 3 inches from the bottom of the tank. Now, when you're changing solution or servicing the pump, I always recommend taking that weighted suction strainer out of the solution tank and making sure that nothing's crusting up on the bottom of the weighted suction strainer. So sometimes oftentimes what I'll do is I'll take an old toothbrush and I'll take the weighted suction strainer, put it underwater, and just kind of clean it off in case chlorine or anything else is gathered on the bottom of that and plugged up the weighted suction strainer. So here's a short video on how to replace the tubes. It's going to go through some of the tips and tricks, but I'm also going to go through a couple other things that come up to try to make it easier to change the tubes.
Hey everyone, Mitch here, and we are going to replace the tube on our Stenner Classic pump. First, we need to collapse the roller assembly and remove the tube. Make sure the pump is off and the cord is unplugged. To remove the tube, the roller assembly needs to be collapsed. First, set the feed rate control to 10. Then, unlatch the latches and remove the tube housing cover. What you're going to do is align the 3 holes in the cover with the 3 knurled lugs on the roller assembly. Hold the feed rate securely and use the cover as a wrench and quickly snap, rotating the cover counterclockwise to collapse the roller assembly. Remove the pump tube. Never install a new tube without rinsing the housing and roller assembly and wiping it clean from any chemical residue. In addition, check the housing for cracks and check that the rollers rotate freely and are not seized. Replace the parts as needed. Now we will install the tube and expand the roller assembly. Check the feed rate ring and make sure it's set to 10. After removing the tube housing cover, place the new tube in the pump head. Use your fingers to center the tube over the rollers. Note that we aren't going to expand the roller assembly at this time. We'll do that later. Place the tube housing cover feet first on the tube housing. Attach the front of the latches to the cover lip, then snap the latches back to secure them. Now that the cover is latched, plug the pump in and turn it on. Allow the pump to run the roller assembly in its collapsed position about 2 minutes to relax the tube. Then turn the pump off and unplug the power cord. Remove the tube housing cover and flip it over so you can use it as a tool to expand the roller assembly. The roller assembly needs to be expanded so the tube is pressed against the tube housing wall. Invert the cover and align the 3 holes in the cover with the 3 knurled lugs on the roller assembly. Hold the feed rate securely and use the cover as a wrench and quickly snap, rotating the roller assembly clockwise to expand it. The tube will now be pressed against the tube housing wall. Apply a small amount of aqua shield to the cover bushing only. Don't lubricate the pump tube. Place the tube housing cover feet first on the tube housing. Attach the front of the latches to the cover lip and press the latches back to snap securely. That's it. Simple as that.
Okay, so we went through the tube change on the pump itself. When we're changing the tube, I always recommend when you're engaging the rollers going in the clockwise motion, you'll notice where the video, they were holding down the head. If you don't hold the head down and you're trying to expand the rollers, it will, how can I say it? It will turn the whole head. So you want to try to keep that in place. I have a slide here. If you're using a fixed output model, because you do not have a feed rate control that you can set the 10, the clips will come out of the tube housing, and you can mount those into a little slot on the back of the pump to lock out the motor. If you're running into a case where the shaft itself is rusted and all grungy and giving you fits, I would always recommend taking this little clip out of the side of the tube housing and mounting it into the back of the pump too, and that'll give you a little bit more leverage to lock out that motor. So a few things you don't want to do is we just remind people, don't lubricate the tubes. Make sure the pump's centered. If you need to center the tube, we recommend turning it a little bit just to kind of on one end, just to try to walk it through on the rollers. When you're changing the ferrules, we recommend just cutting off the end of the tube just to get a nice, clean, straight seal. And then also change the duckbill when you're changing the tube. So I want to go back here. Couple of things that they don't point out here that I feel are important, and it's better if I just review it with everybody. When we're changing the tube, they mentioned run the tube with the rollers collapsed for about 2 minutes. if you're running a number 1 tube or number 2 tube, running the rollers collapsed before expanding it will help exercise the rubber. That often works with the number 1 and 2 tubes, and that's usually adequate. When we're putting a number 7 tube in, I'm sure everybody could attest to how difficult it is to stretch a number 7 tube into a pump. When you're stretching the number 7 and pulling it into the tube housing, leave the rollers collapse, and before expanding the rollers, I always recommend running that roller set at least 5 minutes to really get the rubber exercised well before expanding. Otherwise, you will fight the pump, and you're going to have a difficult time expanding those rollers if that rubber is not exercised properly. We talked about it back. Whenever new tubes are sent out, it's always printed with the tube number on the tube. Most cases, that print wears off. So we always have the number for that tube embossed into plastic on the end of the tube sleeve. So if a customer needs a replacement tube, first place I would have them look is for the number on the tube sleeve. From here, we go to the feed rate control. This is the dial that's just behind the pump or the tube housing. Feed rate control is made up of several different parts. So when you open this up, you'll have 3 screws on the back, the cover, then you go into the ring and the variable cam, and then the lifter. Most cases that most people just leave the lifter all in one piece. The index plate, if the index plate becomes worn on one side, if you see hesitation or skipping, you can always take the index plate, turn it over, and use the back side. So with the feed rate control is going to adjust the flow rate of the pump based off the tube that's inside or on the pump itself with the gearing. And what's going to happen on this is that when you look at it on the back there, that spider, what it's doing is it's rising and falling. So every time that spider is seated down on the index plate, what that's doing, it's moving the index plate, which is then moving the shaft and then moving the rollers, moving fluid through the pump. The cam that you see pointed on there, that's that white plastic piece. Some people call it a weed whacker. I kind of think of that as almost like a bypass. So what's going to happen is that index plate's going to rise up onto that cam, and then in that position, that's when the pump is not pumping and not moving fluid through the pump. And this gives you a little bit more background on the explosion view. So when you're servicing the feed rate control, if you see that the index plate has worn or rounded holes, that's a sure sign that you would need to either replace or flip the plate over. Flat end on the bottom of the lifter, that'll create issues. And then in many cases, what I see most often are worn index plates and grooves in the cam from that lifter running on the cam. Usually when I see this, I'll usually see this if a pump's running at low setting, somewhere in that 1 to 5 range frequently. So what we're going to do is we're going to go through a little bit of the maintenance to show you how to maintain this, and then we have a video that'll walk us through that, but there's a few points that I want to mention and little tips and tricks that I hear out in the field that we'll go through also.
The feed rate subassembly is unique to Stenner's Peristaltic metering pump in that it is a mechanical control that controls the output.
The feed rate control utilizes a cam and spring-loaded lifter system to control the rotation of the roller assembly in the pump head, which adjusts the output according to the setting on the external dial ring. Inside the feed rate control is a brass spider assembly that consists of a pin and spring inside the holder attached to a lifter. When the pump is on, the spider turns. When the lifter drops into the feed rate control channel, the pin engages the index plate, which rotates the shaft extending through the roller assembly that squeezes the pump tube to dispense the solution. When the lifter rides on the cam, the pin disengages the index plate and the roller assembly does not rotate, resulting in no pumping action. For example, when the dial ring is set on the number 10 setting, the spider assembly is engaged in the index plate the entire time, which will turn the roller assembly the full circumference of the housing. At setting 10, the pump dispenses at its maximum capacity. When the dial ring is set on a lower setting, the pin in the spider is only engaged in the index plate for a short period of time before it is lifted out when the lifter reaches the cam. The roller assembly in the pump head will only turn for a fraction of the circumference, and the pump dispenses at a lower output determined by the setting on the dial ring.
The feed rate is a precision control that consists of mechanical parts that are subject to wear when the external dial ring is set at a lower setting. So the factory recommends selecting the pump model that is closest to the maximum output capacity within the requirements of the application. It is like the wear of brakes on a car, which is dependent on the operator's driving style.
When the feed rate control makes a skipping or ratcheting sound, or the pump output is less than what the setting indicates it should be, one or more of the parts may be worn. The cam, index pin lifter, and index plate work together, and one influences the performance of the others. At the lower dial ring settings, a longer section of cam is exposed to the rotation of the lifter. The lifter continuously riding on the cam can wear a groove in it. If the rounded point on the lifter arm flattens from wear from riding on the cam, it may not fully lift the pin out of the index plate. The pin will make a ratcheting sound from dragging across the plate. The feed rate control will index inconsistently at different settings. A worn cam and/or lifter can cause the index pin to drag across the index plate and elongate its holes. The pin will skip across the holes and cause index malfunction.
At the beginning of the maintenance section, we reviewed installation points that best suit the pump. The vertical mount with the pump head pointing in the downward position is important for the feed rate control too.
Corrosive chemical intrusion can corrode the index pin and/or the lifter, causing them to seize. The feed rate will malfunction and the parts will need to be replaced.
With the modular subassemblies, a new feed rate can be snapped on quickly, but the parts are just as easy to replace.
To replace parts in the feed rate control, disconnect power to the pump. Separate the feed rate control and the pump head from the motor. Remove and set aside 3 screws, feed rate mounting plate, dial ring. When removing the dial ring, observe how the cam is installed. Then, remove the brass spider assembly. Remove the old cam and discard. If required, remove the index pin assembly by unscrewing with a box wrench and replace the index pin lifter. The index plate can be inverted to the other side or replaced. Clean out the feed rate control channel before installing the new cam. Apply Aqua Shield to lubricate the cam's angled tip. Feed the angled cam tip into the feed rate control channel and keep the 90-degree end in the up position. Place a thumb over the cam to guide it as it is inserted in the channel. Continue to feed the cam in the channel until there is approximately a 1/2 inch gap between the cam tip and the beginning of the channel. Place the dial ring boss onto the cam's 90-degree end. While keeping the 90-degree end in the dial ring boss and the cam in the feed rate control channel, in a clockwise motion, place the dial ring onto the feed rate control housing and snap into place. Apply approximately 1 ounce of Aqua Shield to the bottom of the feed rate control housing and to the top of the index plate. Place the spider assembly on the index plate. The lifter tip should be positioned in the 1/2 inch gap in the feed rate control channel. To secure the mounting plate, align the plate arrow with the feed rate control housing arrow and install the 3 screws. If the screws are over-tightened, the dial ring can be difficult to turn. If the screws are too loose, the dial ring can be inadvertently turned to setting 10 by the motor.
So when we were talking about the feed rate control, they mentioned a couple of things in there. They mentioned putting the screws on the back of the cover. One thing I recommend when we're putting those screws back in on the back cover, there's a arrow that's embossed on the back side of that cover. What you want to do is you want to match that up with the arrow that's on the outside of the outer ring of the feed rate control. So that'll make lining up the cover very easy. When you put the screws into the back of the cover, I always recommend putting the screws in there, doing 1 full turn backwards, and then hand tighten them into the feed rate control. The reason why you want to turn them backwards 1 quick turn is that you don't want to cross thread the metal into the plastic. When you're tightening the screws onto the feed rate control, hand tighten them, but only hand tighten them a very small amount with about 5 psi pressure as far as tightening. You don't need a whole lot, so I don't recommend taking the screws and then monkey tightening them to the point where they're seated real tight in there. If you tighten the screws too much, you will not be able to turn the ring. And I've had some guys that'll just assemble away, tighten up the feed rate control, over tighten the screws, put the feed rate control back on the motor, put the tube housing in place, put their tube in, and then they realize that they can't adjust the feed rate control because they over tightened the screws on the back of the feed rate control. So just make sure you're not putting a whole lot of pressure on there. Another point, when you're putting the cam in place on the outer ring, they recommend putting the cam in and then putting the rest of the parts in. And what I've found is that in some cases that ring will pop off if you do it that way. So I always recommend putting your aqua shield in, putting your index plate in, and then putting the the cam in, and then your spider in place. And when you put the outer ring in place, you're going to see 3 holes on the outer ring. The only place that you'll be able to fit the cam is in the largest hole. So that makes it real simple. Our engineers designed it so that there's only one way to connect that outer ring. So what we're going to do is we're going to go through a little product review. There's a couple items aside from the classic pump that I want to review with everyone. Items that are used quite often in the water conditioning market, and then one which is a new item that we came out with. So first off, the QuickPro line. This is something that we just talked about in detail, the classic single head and then the classic double head with the 20-to-1 turn down ratio. Where you would use a fixed pump, fixed pumps would typically be used in cases where you're connecting the pump to a pump control module, which is then connected to a water meter. So in some home applications, if you want to try to eliminate going to the feed rate control, you can do that with a fixed pump by connecting it to a pump control module. The classic is just easy. It's an easy, simple design, easy to maintain with the different tube sizes. One pump I wanted to mention is that's new is our SVI SF pump. So it's Stenner. In some cases, what we find is that the classic pump, because it's a brushed motor design, what will happen is that sometimes the brushes will wear out, the rotor or the coil will rust when it's exposed to chlorine and acid. So with this pump, we wanted to come up with a pump that was going to provide not only an adjustable version, but also a fixed rate version. And then we also wanted to offer it with a little bit higher flow rate. So we have the standard 40 gallon per day pump on the very top there. And then we have a new version with a larger 3/8 inch tube that'll deliver up to 60 gallons per day. And we see this being used in municipal applications for that higher flow side. But if you're in an area where the pump is being subjected to water in an outdoor application or susceptible to corrosion, this pump would be ideal. And what makes it so unique is that the NEMA 4X enclosure seals the motor. We have a better bearing set on this pump than we do on the classic pump. We can also change the tubes the same way as you would on a classic pump with the cover. And then also the pump is designed with a new leak detect feature. So if a tube does leak, you have the option to turn the pump off without fluid flowing all over the place. Now we have two different versions. We have the fixed rate version, which we see here, and you'll notice over here the display will show a run signal, which will be green. It'll turn red if it starts to fault. You can put the pump in standby mode. It'll tell you if there's a leak, and then it'll also tell you when there's power. So it just some basic controls, and then the pump itself then would connect to a control system. But with this higher output flow and the larger head, leak detection, variable speed, variable speed, which is on the next pump. I'm sorry, I left it on here. The pump itself also meets all of the requirements for NSF, and then NSF 61, 372, and then NSF 50. Moving on from our fixed, we have our variable speed control. And with this, you're going to still have the leak detect, the NEMA 4X enclosure, the indicator lights here, which will show the run fault, standby, leak detect, and power. But instead of having a feed rate control, everything is turned by a potentiometer dial. So on this, you can do all of your adjustments just by changing the dial. And the nice part about this pump is that when it comes to maintenance, there's no gear case, there's no feed rate control. All you have to worry about is just the tube, the rollers, and then the housing. And we're also able to get a lower turndown ratio. So if you wanted to run this pump at 5% or a very low setting, you can do that with this pump without damaging any of the internal motor parts. With it being a brushless motor, the pump is also designed with a splined shaft versus a D shaft on our classic pump. And with the splined shaft, that's allowing the rollers to run smoothly at very low settings, and you're not going to damage the pump in any way, shape, or form. Another line that's very popular in the water conditioning market is our Econ Series pump. Econ Series pump works off of a dry contact switch on a water meter. So anytime water is moving through, it will activate this pump. Econ line comes with the shorter tube. Very simple design with a cover that'll slip on and off. The pump itself has PSI pressure rating up to 80 PSI. As far as the pump's concerned, if you're running a system that's close to 70 PSI, I'd recommend going to a classic pump. What we found is that when you're going near the top threshold or very close to that top rating on the PSI for the pump, you're going to wear out the tubes a little bit quicker. So this pump, you can connect it to a water meter. It can also be connected to the heads on water softeners to trigger the pump on and off too. So this is a great alternative out there if you're working in that 40 to 60 PSI range or lower. I also mentioned this pump, which is called the integrator. If you have any, most cases, if you're working with farmers, if they have a pump on their home well system, if they have livestock, in many cases, they're finding that they need to condition the water for their farm animals because it helps the animals grow faster and keeps disease down for the animals. And in this case, the difference between our FP and our integrator is that the integrator has a relay that'll be able to connect and speak to the control systems that you'll often find in barns. Now, when we talk about meter systems, we have a couple different options here. I was talking about the fixed pump hooked up to the pump control modules. These are just a couple systems we have. We have the same systems as we had shown before for the FP. You could purchase the systems completely set up and mounted on a panel like this, and all you have to do is screw a bracket into the wall and then hang this on the bracket. It just makes for a nice, clean, simple, easy installation, reduces the amount of labor time that you have at a customer, and just makes it a little bit cleaner and easier to set up. Here are some more examples of the Econ FP. The one on the left is very popular in the water conditioning market, and I know Nelson sells a good number of these. This is just the Econ FP that I had shown before, but connected to the water meter already set up. And you can specify your inlet as far as 3/4 inch, 1 inch. It all depends on what you're working with for your customer. Accessories. We do offer the solution tanks with the ability to mount the pump onto the tank in 7.5, 15, and 30-gallon versions. You can also purchase the tanks separately if you need. The pump control module, which I mentioned, this is the unit in which the classic pump would connect into. So you would plug the classic pump in here, and then where your feed rate control would normally be on the pump is now taken over by a switch on the side of the feed rate control. And your flow is then determined based off percentage and runtime, depending on the chemicals that you're dispensing. Water meters, we have them available: plastic 3/4 to 1 inch, stainless steel up to 2 inch. And these can be used with the classic pump, the Econ FP, the integrators. We also have flow switches and available in 3/4 and 1 inch. I have customers that use this in home water conditioning applications. My only word of caution on the flow switches is that they do not operate very well at very low flow rates. I've had cases where they've set these up in customers' homes, and the customers will say, I'm running the water in the bathroom sink, and I don't hear the pump turn on. If you're pumping at a very low flow rate, it will not activate the pump, and the switch will not. This flow switch will not activate if you do not have enough flow going. So if you have some low flow applications, I always recommend going with the meter. Let me just give you an idea as far as the flow rate minimum on this. Flow rate minimum on this is 1.9 gallons per minute. So if there is somebody that's running a sink just for in the bathroom just for a very short period of time, there's a possibility that a flow switch might not be the best choice for activating the pump. Flow indicators, which we mentioned before, to give you that positive flow indication. And then here's our complete line as far as the classic Econ line, and then our meter and flow indicator systems. If you ever have any questions as far as sizing the pump, owner's manuals, specifications, photos, the videos that I had shown to you, along with some other videos, are all on our website under our support tab there. You can see where we have the videos of, so if you need to send a video to a customer, you can certainly link them to our YouTube videos, which are online. We also have the ability, if you are not sure about how to size the pump, we have tech support people that can help you size it, help you determine runtime on the Econ FP pumps. So there's various different things that we can help you with. And if you need sell sheets or anything like that, specification sheets, that's all online on individual tabs for each product that we sell, along with the owner's manuals. Any questions? I'm going to switch back to the video here. On here.